the server farms running the NVIDIA Blackwell chips are running them at around 70 to 80% cycle rate. Okay. And they are burning out at 33% a year. And because they're buying them and it's an expensive purchase, right? Anytime you buy these things. So the companies buying them are amortizing them over 7 years, like you would any large purchase as a business. But at year 3, they're already at like 120 something percent of the year 1 purchases, and they're not accelerating those write-downs. Okay. Mm-hmm. And so
welcome to Fire Talks by Tech Wing Bites. I'm Clint. I've built software, led teams, and now a founder, helping builders who are ready to make the leap but can't quite see the path yet. Every episode is one conversation closer to clarity on ownership, execution, and momentum.
Today is going to revolve around AI chips, but of course, if you have something you want to share, that's fine. I sent you the email. I assume you had a chance to glance at it.
It's a couple. It's a couple of them.
Yeah. And I'm gonna go ahead and put him on the spot. David is our pro. But let's at least do some introductions. All of you guys know who I am. Hassan is my business partner. He helped me out with Tech Wing Management as we continue to build. But Hassan, do you want to go ahead and introduce yourself?
I'm Hassan Fazet, Clint's business partner, helped him build Tech Wing Management. But no, I'm more of a operations / nonprofit grants type guy, and I know enough about and on the technology side to be dangerous, but definitely looking forward to hearing what you guys have to say, and then being able to get you guys to explain it in layman's terms, so that I can be able to kind of grasp it. So I always enjoy these talks.
Wonderful. Kevin?
Hello, everybody. My name is Kevin. Right now, I'm in the process of, I've been researching and developing a business for a while, actually, which is funny. But 2026 is the year that I'm going to put a lot of things in motion. Basically, what it is it's like a method of generating funds that utilizes crypto, art, and various other media mechanisms to generate passive income for people. So it's just a matter of putting it together and making it happen. But it's good to join you guys and listen to your thoughts.
David?
Yeah,
thank you,
sure.
Kevin.
So my name's David Seaholm. Been around technology since I was a young kid. Grew up with my uncle was an IBM engineer. My father did UX before UX was a termed thing for the government. And went to school for computer science and electrical engineering. Built a business when I was in school so that I could eat, and fell in love with business process as part of that. Became a technology executive basically my entire career. I'm also in the middle of starting my own businesses at the moment, which is it's been an interesting year. So yeah, that's my background. A lot of hardware, a lot of software stuff background. So
thank you, David. Tony?
Oh, it's on me now, right? Okay.
Yeah.
Oh, yeah. So yeah, Tony Brooms. I've been in technology for quite a bit. Actually, kind of similar to you, Dave, but in this case, it was my brother, my older brother. He was a IBM salesperson, so he actually brought home my first computer, which is the IBM PC Junior. But I've been doing technology, computer science for a while now. Started my own business called Ola Billy. So what we aim to do is really bring invoicing to a simpler way of doing things, right? So we actually employ text messaging in order to facilitate that transaction between client and customer. And so, yeah, that's what we've been doing, and using a bit of AI to kind of to push it along. So we've been learning as we go, and yeah, that's been where I am so far.
Thank you. Thank you. Yeah. I met with Tony a couple episodes back, and he showed me ngrok, and I've been all over it. Ngrok. Well, I might say it wrong. Why don't you tell him what ngrok is? Because I might say it wrong.
I mean, it's basically a tunnel. It's a way for you to, well, at least what I use it for is I kind of spin up my things locally, but at this point I'm also able to host it on the web, so I can have access directly to my system when I try to test things out locally. So, part of what we're doing, part of what I do is, there's a front end system and a back end system. So this allows me to test out the whole process without having to push everything up to a production environment.
Pretty cool stuff.
Yeah, it's a tunnel which helps you do that basically.
Yeah. Thank you for sharing that.
Yeah.
So I dove through those videos, and I did know a little bit about the regular GPTs, right? And chips, the AI chips, and going through those videos, seeing, and of course through conversations with David about the Google whatever the acronym is. What's the acronym?
You.
Yeah, TPU. That's it, right? But what I didn't know is there's so many people making chips. I actually know a friend who actually work on the chip level. He's not doing like software programming, but chip programming, specifically AI chip programming. So I didn't realize how much of a big deal it is. And to see Apple entering into the race now by I guess they're thinking about it from the sense of adding AI chips to their devices, so that you can pretty much run LLMs locally. I think the goal it seems like the goal is, since the security around AI is seemingly a challenge, maybe people just trying to have like an internal network, and that begins with the chip. But that's one of the points that came out for me. What was y'all thoughts?
I think that the security aspect is a selling point for the manufacturers. That's not reality. It's not what they're trying to. They're trying to offload work onto the devices and consume your power and not theirs. Right, and it's more responsive and other things, but yeah, especially on the query side. So when you formulate, your prompt to whichever LLM that you're going to send it out to, they then have to go and build the whole vector space for that prompt and process that. So anything that they can do about organizing that or getting it that vector ready before it gets to their systems, it helps them out massively. So
what does ready in context mean?
Well, I mean, just turning it into a vector for one.
Just turn it into the vector.
Yeah.
Okay. Interesting.
Yeah.
But when it comes to chips, though, like one of the biggest kryptonite per se is just energy, right? More and more power, more and more power. That's how I understood it. Are you seeing it the same?
I mean, you're talking about for the on-device chips that. I mean, by the way, those
sorry, go ahead.
Those are already there. They're already in the devices. But
but when you look at it from a large scale, from these organizations, Microsoft and so on, housing these chips, then it comes down to more and more power, more and more infrastructure. So when you put it on the phone with our lithium batteries and our laptops in the future, I mean, yes, some of it is there, but I'm saying progressively, do you think those devices then would pull more energy?
Exactly, which means the battery life isn't going to last as long.
Right. That's exactly what I was getting.
Yeah. So again, it goes back to the selling point, right? It's like, but it's more secure for you because your information is not, going directly to whoever it is that you're sending it to. Well, you're going to send it there anyway.
You're still getting it.
Yeah.
It feels almost like it's almost like not modern, because this has always been modern, but it's like a client server architecture, right? So they offload a lot of that information onto your device, which is essentially the client, and
Right.
then sends it up to the server to eventually, not generate the vector, but to utilize the vector that was generated on the client side to then go into the space and you search and figure out what the query and the answers to that question that was built out on the client. So they've offloaded some of that to you in order to make it a bit more efficient for themselves.
Yeah. So for instance, like,
Oh.
have you started using projects inside of Anthropic yet, inside of Claude?
I've used Claude.
So you have like all your files and everything sitting there,
Mhm.
so you have it your own kind of surface that you've provided it. If you can offload that surface onto the device instead of up in their server, that's a huge cost savings for them, right?
Mhm.
And that's part of building out that vector space. It's not just like, okay, I'm going to take your prompt, I'm going to vectorize it, and then I'm going to send it. Like that's you could do that on a normal, whatever architecture CPU. But if you're talking about going and organizing the context space or the surface that you're providing off of the device, that's where this type of stuff starts to play in.
So,
Yeah.
so as the layperson in the back of the room,
Mhm.
I'm hearing you guys talk about this, and of course, when and Clint, I think you and I talked about this a little bit when I was in Austin, right? About um, creating it using AI and having it learn you, and in pretty much a safe environment, right? Because it's not open to everyone else, and it looks like what you guys are saying. Um, they're the selling point as a salesperson, because I see this as a selling point, is saying, hey, this is so much more secure and you guys will be able to utilize AI without feeling like you're sharing it with the whole world, when in essence you're going to. It's just, you can start creating things in that secure space, and realizing, because only people like you guys are going to know that, hey, the reason why they're doing this is because they're trying to offload the power consumption on you
Right.
as the user. Right. And so, because if you guys would have never said this, I'd have been like, this is the coolest thing ever. I can do my AI in this. And so, when David jumped out and said, oh, yeah, this is not going to work because blah, blah, blah. And I'd have like,
Yeah.
yeah, it probably won't work for you because I never thought about that and would not have thought about it had you not brought that up.
I mean, but is secure sounds to me like the selling point, but the real benefit is speed, isn't it? Like efficiency.
I mean,
Price.
I mean, right? Because if the server is doing some work and your device is doing some work, yeah, there's some secure tunneling going on, but they're not really covering any major security grounds there. It's like the same
well,
stuff we got today.
yeah, I mean, other than your surfaces lives on your devices instead of up in the whatever cloud, but then you're also on the flip side, you have to have your surface on every single device you're using it from. Like right now with Claude projects, I can use it off my phone, I can use it off my computer, I can go grab a tablet or whatever, and I get to the same surface every single place. But I think it's trying to address the power issues that they already have, right? So they don't have and are not going to have the power to continue scaling this for the next decade.
Yeah.
We don't even have the equipment to build this stuff out. I mean, like if you are in the market to go buy a transformer, like you're going to wait 2 years to get it.
Yeah. So like you say that, and this is me being devil's advocate, right? Like a couple years back, they were projecting the cost for all of these different devices that we need for the AI ecosystem. And it was expensive. And the video is like, yo, this is how much it costs, blah, blah, blah. And then DeepSeek came out and say, yo, you can run this on this cheap hardware. So the question is, as we see it now, it is expensive and it's a lot and we don't have, but would China come out with something tomorrow?
Well, they already have. They're an ex Google engineer just put out.
I saw that.
Yeah.
Go ahead and explain it.
Yeah.
I mean that effectively it's a clone of the Google chips. I forget the name of them.
Yeah, I saw that in passing.
Was
I
like
didn't dig too
RT or
deep in it.
something.
What was it saying? What
Was
was
it
it saying?
Tensor RT or something like that? I remember hearing about it, but I can't remember.
Yeah, you're right. It's a tensor chip line. Yeah, effectively, it's a clone of those. But yeah, it's a low cost AMU chip that China's going to start developing. I think that so the problem with China is they're cut out from Taiwan Semiconductor and TSMC. So they can't get stuff built by TSMC directly. They have to go, through buying stuff through shell corporations, even get it into their country because it's illegal to export it there. Anything at 5 nanometers or below that applies to TSMC. I think that China has the ability to do 7 nanometer. They have the right litho equipment. They can't get parts for it necessarily easily. Okay, so anything 7 nanometers and above, they can build themselves. And this chip on the tensor, but it's at 7 nanometers instead of the 5 below that Google and these other companies are building it at. So it's not as efficient, but it's cheap,
Right.
cheap to make, and yeah,
And hence probably cheap to connect in series and scale, possibly.
Oh well, yeah. I mean, but everything's really cheap when you have giant, weaker prison population to run all that for you. So
Yeah. So what do you see the downsides, right? Because here you have this Google developer creating this chip. Of course, it's low level, but it's still pretty powerful, right? And then you have the Googles and the Apples, and they just competing on this high scale. But to what end? You know what I mean? Like for what speed? Like they say to replace developers, but I think that's going to come to a crashing halt soon.
well, I mean,
yeah, probably more than replacing developers. I mean,
yeah,
it's the replacement of
factories,
a
probably
lot of workforce, right? It's
yeah.
what AI is in the long run is supposed to be doing the work of what people do. It's, but how far along the line do you get, and how far along we are with that? And we're pretty far away from something like that happening.
Yeah. Well, I didn't do as much digging, but I slightly saw that. And so NVIDIA, so for you, Hassan, NVIDIA has been making good graphics cards for a while, and the design of their chips just works for AI, right? And NVIDIA's biggest competition with video cards, mostly for video games, is AMD.
Yeah.
And I'm not hearing much from AMD, and that feels weird to me.
So AMD does the what are they called? The FPGAs. Yeah. So they're basically programmable gates that you can connect in line with a bunch of processors, and so you can create. Basically what you can do is you can create your own AMU or TPU or whatever it is thing that you want by configuring it. It's nowhere near as efficient as if you actually have one of those, but those are special chips for a very special purpose. I think for anybody that's not super technical on how chips are designed, you can think of so you have a city street, right? Or a city with streets in it, and you can choose what route you want to go to get to point B, right? Then if you take that concept and it's okay, that's like a graphics processor unit. Like you can choose however you want to get there. There's a million different ways. You could change it up every day if you wanted to. Then think about like the little kid's toy where you get the little ball to go through the maze, right? There's only one way to get to the very end, right? And that's what a TPU or AMU is. It has a path that you can take, and you can do it over and over and over again extremely quickly, but it's not multi-purposed. So and AMD is going to stick around with those programmable systems, specifically for being able to design your networks or your systems for the TPUs or AMUs or the 500 other architectures you have out there for doing specialized processes. but their market share is going to continue to shrink. Right now, you have entire clusters inside of servers that can be rented for AMD FPGAs.
Yeah. So that makes sense because I'm watching the video and some stuff is making sense and some stuff doesn't. So thank you for clarity because now I'm reflecting back on one of those videos I was explaining that. So it seems like then the newer chips is just providing more and more paths.
It's a specific path.
Less.
Yeah.
Less paths.
Yeah.
So faster to get from point A to point B.
Right. It's less complex.
Gotcha.
Right. Like you. So when you like do your pipelining and everything, right? Have to. It's super simple. I mean, it just sits there. Did you ever study Cray vector machines?
I have not.
Okay.
Tony, you?
That's I might have did it a long time ago, but
like, you would have only seen it in school. I mean, those are super. I mean,
it's like a simple language.
3 of them, something.
All right. Huh. So it's like faster from point A to point B, and then the visuals that I'm reflecting on was like they're putting layers on top of layers on top of layers, which would makes it even more faster. I assume.
Yes.
With these chips, huh? Interesting.
Sort of. Yeah, that's a sufficient way to think about it.
So this might sound like a dumb question. So these are the GPUs, right? But the regular chips, how are they designed? I guess in quote unquote inefficiently to use AI. I'm talking about the other chips such as the Intels, the ones that goes into your computers, the non-GPUs, the CPUs. How are they different? Why were they not used instead of GPUs? I know GPUs is because of faster processing, because of the imagery, graphics and whatnot.
Yeah.
So this is why. But
yeah, I think part of it had to do with the fact that with GPUs, they were designed specifically to calculate these number crunch essentially. Because when you're talking about graphics, you're talking about a lot of matrix math, essentially.
Right.
To try and design to figure out where you are in in 3D space specifically. So that's a lot of calculations, and I think CPUs are much more generalized. Like they're designed to do a lot more different things, whereas GPUs were very specialized for that. And I mean, it almost feels like NVIDIA AI or NVIDIA stumbled into it just because they were the ones they had the GPUs.
Feels that way, yeah.
It feels that way. I mean, I'm sure there was more to it than that, obviously. Yeah, because you don't just stumble into things like that. But
go ahead, sorry.
Yeah, but it just feels. But as far as GPUs are concerned, they're a specialized chip that does the calculations quicker than a CPU normally does, and in parallel.
So how does this relate to in 2020 I wanted to buy a new video card and I couldn't get it because they were all being used for crypto. So how does these same cards that's being used for AI affect like the crypto market?
They weren't super efficient for that, but they were better than okay. So all right, so on a regular CPU that you have in your computer, right? It was advertised as having X number of cores, right? Okay. Each core, so you have your pipeline of instructions, right? And so anytime that the next clock cycle comes, it's going to execute an instruction. Okay. Right. So if your computer has 4 cores, it could conceivably do 4 instructions every clock cycle. A GPU, most of them have hundreds, some of them thousands of cores, right? And so they can do that many instructions in a single cycle, but their pipelines aren't as complex. They can't do as complex calculations. They literally do dot product and cross products of matrices. That's what they do. Okay, so yeah, I mean that answers your question. So if you need to crunch lots and lots of information to be able to get to an answer, and you can cross product or a dot product.
Wow, I'm learning some stuff. And Hassan, Kevin, I know that some of this stuff might be going over your head. So if you have any quick questions, this is the time. What's your questions? You want them to explain what vector is?
No, it's been a very interesting conversation. I have a general understanding of everything that's being said. I'm really curious, and I know it's way too early to have this conversation, but I always like to just throw stuff out just to get people's ideas and feedback. But I guess the question is who's going to win, the trip race overall, which of course, like I said, it's impossible to predict, but it's a fun thought process, right? NVIDIA has a huge lead over everybody else, but even with the recent purchase of Grok, they just took on Grok that was a former potential competitor. There's the overseas competition. Samsung is part of the Google pipeline. So I think that's what I would throw out there is like, how do you see the landscape just, even if it's just 2026, like I wouldn't say like who's going to win it all in the end. I think that's a little ridiculous. But do you think NVIDIA keeps its stranglehold as far as being the dominant player, or do you think there's any upstarts coming up that we should pay attention to?
I'll say what my take on that is first, because I'd say the overall winner is not even going to be like NVIDIA or Google. It's going to be TSMC because they're the ones building everything. They're the ones that build. Everybody goes to them to build it. So they're going to be the ultimate winner. But
that's the one in Arizona, not the one in the Netherlands, right? Because I think Netherlands creates chips too.
They didn't.
That's Taiwan. They're Taiwan.
Yeah,
Taiwan. Okay.
Taiwan. I think they do have. They built out. They made one in Arizona, but I don't think that one is ready to make the sub fives yet. 5 nanometer yet.
No.
Okay.
But I'm sure they'll be coming really quickly.
Sorry.
What were you saying?
The one in Arizona just started making chips for Apple like a week and a half ago or something like that.
Oh, okay.
Oh. Okay. That's a different story.
Yeah, their efficiency is probably trash right now. They're just getting started.
So my question is, with this whole chip thing and how it's going to affect your average everyday startup or small business.
Mm-hmm.
What exists in that doesn't exist today that's going to give me some type of advantage in running my business or starting my business or being able to take my business to the next level?
Do you have an answer to that one, Tony?
Yeah, Tony.
My take on that is I wouldn't be too concerned with the chips so much as the service for that, just because what you're doing as a business, as a small business, I mean, what I'm doing as a small business is really finding the AI tools that is going to help me work faster and help me get my product out quicker, get it out the door. I honestly don't necessarily care if that is NVIDIA, if they're running on NVIDIA chips, if they're running on Google chips, because for you, for me, for anybody that's that level, we're concerned with the service. We're not concerned with that other speed, the speed of the chip per se.
Yeah,
right.
I largely agree with that. Like, I think that the winners in business in general with AI right now, or large language models as it really is, are people that are looking for building efficiency into their process, right? Force multiplication. The losers are people that are trying to replace people or processes. It's not there. There's too much nuance that we haven't figured out how to deal with, and the consistency of answers are not there either. The models need to be more mature and etc. I mean, there's just so many different things. I would say that I think that paying attention to the chip market though is important. Somebody just mentioned Grok a minute ago, and and NVIDIA's purchase of ngrok, and it being slated as a strategic purchase or whatever, right? But
Wait a minute, is it ngrok or grok with a Q?
oh, sorry, it's grok.
Yeah, I didn't realize that. I was like, predicted.
Yeah,
The
no,
grok is
they're
that's the
completely
server.
different guys. Sorry, there's too many. There's like
Too many groks. There's Twitter grok.
In any case, yeah. So the grok, the one that NVIDIA purchased, that was a bailout. They were about to fold.
Thanks for sharing that.
Yeah, they were one of the companies. So we kind of talked about this a little bit last time, but NVIDIA has gotten itself into this cycle. So I guess I need to step back a little bit. The server farms running the NVIDIA Blackwell chips are running them at around 70 to 80% cycle rate. Okay. And they are burning out at 33% a year. And because they're buying them, and there is an expensive purchase, right? Anytime you buy these things. So the companies buying them are amortizing them over 7 years, like you would any large purchase as a business. But at year 3, they're already at like 120 something percent of the year 1 purchases, and they're not accelerating those write-downs. Okay. And so to continue getting the purchases at this rate, already like people are talking about, oh, well, you're not gonna be able to scale, the investment that's going to take is going to be X, Y, and Z, and they're doing this off of the financials that are being reported by these companies and going and looking at it. Then you go actually look at what's actually happening. The problem's even worse, right? Because they're burning through these things way too fast. So NVIDIA started investing in companies that are buying large numbers of NVIDIA chips, and they are giving them grants. Those grants come with all sorts of strings attached to them. You have to use NVIDIA chips, blah, blah, blah. But they're burning out these crazy fast, right? Because, their general purpose, it's not what they were intended for. They're definitely not intended to run continuously at 80% cycle rates. So a couple of companies, NVIDIA has bailed out 2 now that I know of, Grok and somebody else I can't remember the name of, where they just flat out purchased them when they were about to go under to continue getting them to buy their chips, right? Because now NVIDIA owns it and they can play some tricks with their books. So to that end, I think it is important is going back to the original question about paying attention to stuff for your small business, because you don't want to end up on a service where they're going to either fold or get folded into somebody and that service isn't around anymore if you begin to rely on it.
That's a great point. That's a great point. Thank you for clarifying that and sharing that information.
Yeah.
And just to clarify even further, what you're saying is, and you said something that I think will resonate, because you have a lot of people who don't know a lot about AI and don't even realize that they use AI, every day, unbeknownst to them.
Sure.
But you said that the winners are people who are using AI for efficiency, right? And the losers are people who are trying to replace people or replace processes. And because AI is not there yet. And I think that's important to hear, important to say, because there are so many people that are just like, they don't even want to touch AI just because they think like, yeah, well, I don't want my team thinking that I'm trying to replace anybody by using this AI, not understanding that AI is a better partner than it is a boss, right? And so I just want to say I appreciate you for bringing that out.
Hey, what's up? I'm Clint. Thank you for hanging out with me on this one. If you're listening or watching this cut, the full episode is on techwingman.substack.com. Go subscribe. It's worth it. And if you're already a paid member, you're good. Keep watching. Either way, I'd love to hear your thoughts. I actually read that stuff. All right, back to the episode. Hey, one more thing. I know I don't always talk directly to who's watching and listening. I'm still figuring out this podcast thing. Bear with me as I build. I appreciate you being here, though, and staying with me this far. Thanks again.